So here we are demonstrating speed control of brushless DC motor using Leo converter. So here we are going to control this 1000 kV BLDC motor as a brushless DC motor. There we have the two stages, mainly for the Leo boost converter, and the next is VSI, voltage source inverter. Why? Because when we control the BLDC motor, then we need to provide the three-phase input to that. So using these three wires, we are going to provide the three-phase inputs, and then only we can on the BLDC motor. Then by controlling the voltage which is coming out from this Leo converter, there we are going to control the speed of this BLDC motor. So here the main power flow is 230 volts AC input to this step down transformer, which will take 230 volts AC and provide us the 12 volts DC output. 12 volts AC. So step down transformer is 230 volts to 12 volts AC. And here we are using KBL 10 rectifier IC, which will convert the AC input to pulsating DC output, and after this capacitor we will get the pure DC of 12 volts. And then we are using the LM2596 voltage regulator, which is providing the 5 volts DC output as the operating voltage of our microcontroller, and LCD display and PIC microcontroller and IR sensor is 5 volts. So here this 5 volts is input to this Leo boost converter. This will convert that 5 volts to 12 volts DC output, which is the operating voltage of our BLDC motor. So here we are using Leo boost converter purpose is like which will convert the unregulated power supply to regulated power supply. Why? Because when we are running a BLDC motor, there will be chances of producing of harmonics, which is heavily in normal DC motors. So when the BLDC motor runs, we'll get the more harmonics that will be neutralized by this Leo boost converter, and it will regulate that to the 12 volts DC output. That will be done by our Atmega microcontroller. And here we are using PIC microcontroller in order to make this controlling of the BLDC motor speed is closed loop. Means we are going to set the speed from this potentiometer. Instead is 0. So we are going to increasing the speed, and that speed will be set to the BLDC motor by using Atmega microcontroller, and it will get the feedback from the microcontroller PIC 16F72 microcontroller through this IR sensor. Means set the speed, and whether the speed was set to the same level was not set it or not, that will be monitored by this IR sensor through the microcontroller to the Atmega microcontroller. So here the stages like step down transformer, rectification, regulation, Leo boost converter, potentiometer, and LCD display to continuously see the set speed was properly set or not, and Atmega microcontroller to control to get the input from the potentiometer and to control the voltage source inverter, and a microcontroller to make this set speed was in closed loop through this IR sensor. And this is a BLDC motor which is of 12 volts DC operated, and this is the breadboard to distribute the so-called 5 volts power supply throughout the input and output modules. Okay, so let us see the demonstration. So here there is a small setups will be there. After you on that, you should get the beeps once, then the 3 beeps should be come out, then only we can set the speed. Otherwise you need to restart this microcontroller. So the beeps has to be come. So let's run now again. So like that the 3 beeps has to become. So when the voltage is minimum raised after the 450, then only we can start the motor. So maximum set speed is 1023. So don't run at the high speed. There will be chances of getting heat from this MOSFETs and rectifier ICs. Slowly you can decrease the speed. Slow speed and high speed. So whether you are increasing or decreasing the speed, don't go with faster manner, just slowly increase or decrease the speed. It's only safety purpose of the MOSFETs and rectifier ICs. Right, coming to the interfacing connections. So we have interfaced the Leo boost converter MOSFETs at the Atmega microcontroller at pin number 9, and here A0, A1, A2, C0, C1, C2 interfaced to these 6 MOSFETs through the Atmega microcontroller, and LCD interface at the pin number 2 to pin number 7, and IR sensor at B7 pin for microcontroller. And yeah, this is the main connections of the input and outputs.